Charging electric cars is part of an evolving ecosystem with many different machines and stakeholders that must be able to exchange information automatically. In this video, I will explain how you can use a range of computer protocols to do just that. I've been driving a fully electric vehicles for many years now, and I learned firsthand how uncomfortable it is when chargers are unexpectedly unavailable. Sometimes my battery was so empty that I literally had to push the car the last meters. At other times my wife was friendly enough to tow me home. And occasionally things got so bad that an official tow truck had to take me to my next destination. So I know whereof I speak when I say it's important to do this well. Before I started my second career in renewable energy and electric vehicles, I was leading telecom projects where we rolled out the first mobile phones. I find the lessons I learned there very applicable to the world of charging infrastructure. Now everybody takes it for granted that you only need a contract with one service provider. But this makes sure your phone works everywhere and that you simply get one bill at the end of the month. But creating that system was far from trivial. And with charging infrastructure, we have not yet reached a similar level of maturity. For example, in the Netherlands you can use almost any public charge point using the same RFID card, just swipe. But once you cross the border, things are highly fragmented. I think the situation we should be striving for is the same as the one we take for granted when we use mobile phones. Your car should be able to automatically authenticate you on any network. You should be able to simply plug in and charge everywhere, without excessive roaming charges and with one simple bill at the end of the month. The key to making that happen is open standards, just like we have on the internet. Such open standards enable competition by avoiding lock-in and by enabling new entrants, thus stimulating innovation. These standards connect two of the oldest and largest industries on Earth, energy and mobility. And currently these giants have not yet woken from their slumber. So just as with the internet, we have to be quick before they wake, and then we can still get it right. Such standards do not dictate business models, let's be clear about that. They do not dictate roles or functionalities. They just enable innovation by enabling communication between all parties involved. Let's start with a simple case of EV charging at home to explain what I mean. Let's assume for this case that you have a dedicated charger that is managed by a remote operator, right? For this you need an EV manufacturer, the OEM, the EV itself of course, and a charging station, also referred to as an EVSE or electric vehicle supply equipment. In order for the EV to talk to the charger, the IEC 61851 protocol is often used. New functionality will become available when the ISO 15118 protocol is deployed. Things like authentication and smart charging, even giving energy back to the grid from your car, is automatically handled by the car in that ISO protocol. And perhaps all this looks simple, but to enable this scenario in practice, the charging station should have the option to be remotely controlled by an operator. Let me give you some functionality for which this is necessary. First, metering EV electricity usage. This is often useful to get tax or company money back. Then remote troubleshooting, the charging process. And firmware updates for fixing bugs or adding functionality. This all makes the picture a bit more complex because we need to add the so-called charge point operator, this party that does the remote controlling. The de facto standard for this, the open standard for this, is the OCPP protocol, which stands for Open Charge Point Protocol. Now let's make things a little bit more complex. The user is not charging at home. Imagine you're driving somewhere and you need a public charging station somewhere else. Here we run into the problem that we have different operators for different charging stations. you don't know the charging station operator where you go to in advance. To get one bill at the end of the month, you will need an ID. Currently, usually a charging card, but in the future it will be an app probably. This is provided by a party that is referred to as an e-mobility service provider, the EMSP. That makes it possible for you to use your charge card at any charging station of any operator, but you need some form of communication between the EMSP and the CPO for this to happen. This communication is for authorization purposes and includes the handover of billing data from a CSO to the EMSP, so the EMSP can provide you with one bill. If you want to enable roaming to other networks, and you are not using peer-to-peer or distributed ledger technology like Bitcoin or blockchain, you will also need a clearinghouse. This slide shows different ways to facilitate roaming. The reference documents provided with this course provide a step-by-step walkthrough of all the different scenarios, so I really encourage you to look at that. But I'll give a short overview. As you can see here, there are different protocols available, and you have the choice to do it with and without clearinghouse. An add-on not mentioned here is reserving a charge point in advance, so you know it will be available when you go there. To be able to do this, reserving, information about charging stations should be available, and this implies improving more information about the charge point and of course also the tariff and the availability of the charge point. It's an example of information that can be supplied using roaming protocols, but is not yet widely used. The most extensive example, the last one also, I want to give is smart charging. It will become the norm once we move to smart grids. Smart charging means that you don't automatically charge as quickly as you plug in, and also not automatically as fast as you can. Instead, you take more factors into account. For a customer, this means charging when the price is lowest. For the power system, it means charging when the network is not overloaded. For society, it means using renewable energy in the best possible way. Since cars have big batteries and use a lot of energy, but are also standing around for 23 hours of the day on average, smart charging offers tremendous potential. My Spark City model shows that in the Netherlands, if we apply vehicle to grid, and if more than 20% of the cars is electric and thus smart charging, all daily mismatch between supply and demand can be fully eliminated. No more duck curves. This is even true if all the energy comes from solar panels and windmills. Of course, I'm not talking about eliminating seasonal fluctuations, just daily ones, but still the power of electric vehicles to stabilize the grid is enormous. But with fast smart charging, the stakeholders of the electricity grid come into full play. The DSO, or distributed system operator, provides local electricity and has to watch out for voltage and local grid congestion. The TSO, or transmission system operator, transports electricity over larger distances and has to watch out for the frequency and for grid congestion over larger areas. The BRP, or Balance Responsible Party, is the legal role that encompasses all the bidding that goes on to balance supply and demand on the electricity grid. Really important, always has to be 100% in balance. The protocols for smart charging are not yet completely clear, but many developments are taking place. I recently, for example, wrote a paper about the excellent synergy between OSPP and OpenADR that is used a lot in the United States. In effect, the utilities could use their OpenADR infrastructure, and by connecting it to OSPP-enabled charge points, they could technically start smart charging all connected vehicles. IEEE 2030.5 is another interesting protocol, although at the moment it's primarily aimed at in-house smart grid solutions. However, smart charging is not yet common practice, and currently protocols have limited support for this. OSPP 2.0 is quite new, and it's fully smart charging enabled. But only a few implementations exist where the actual state of charge and time of departure are used from the EV user. One issue is that most EVs simply don't communicate their state of charge to the charge point, so you never know how full their battery is. Another problem is that users often don't provide that time of departure, although you can often predict it using machine learning. Furthermore, renewable energy aspects are not yet taken into account in protocols and functionality. But as the adoption of electric vehicles grow, and as the adoption of distributed and intermittent energy sources like solar and wind grow, and it will both happen, so will the importance of smart charging grow. Before I go to the conclusions, I want to point to two very useful tables, I think myself at least, that are explained in more detail in the supporting material. The first one shows all the different protocols and the currently supported functionality they have. The next table summarizes the maturity, the market adoption, the interoperability, and the openness of the protocols. I'll give two examples. OCPP can be used for the communication between charge point and charge point operator. That's its only application area. But within this area, it scores high on maturity, interoperability, market adoption, openness, and testing tooling. Unfortunately, official certification is still missing. And by the way, version 2.0 is already available. OCPI can be used both for smart charging and for roaming, but especially in the latter capacity, it has more to offer. Okay, let's wrap up. I'm sorry for any confusion I might have caused, but in my defense, there are a lot of protocols that are in use, and the protocols and the way they are used are still emerging. Nevertheless, I hope I've given you a very general overview of the functionalities, stakeholders, and protocols that can be used as the building blocks for a thriving charging infrastructure industry. Smart charging is something that will be increasingly important as more electric vehicles become available and as the use of intermittent and distributed sources of renewable energy grow. It has the advantage for consumers, it has advantages for stakeholders regarding the electricity grid, and it has advantages for society as a whole. My final message in this video is to stress that open protocols will be crucial for the development of charging infrastructure. And those who know the history of the internet also know that creating an innovative and thriving ecosystem through the use of open standards is not a given at all. It's something that requires vigilance and occasionally a hard fight. But I think we'll manage. And I think the charging infrastructure business has a beautiful future ahead of it if we use the protocols. Thank you for your attention.